I'll just report on the Tesla battery day, which underwhelmed a few people. There wasn't really any new news technologically. It was more about the philosophy of Elon Musk. He's basically dedicated to cutting the costs and increasing the capacity to produce batteries so that he can make the EV revolution a reality, and he really does need to do this. He needs to ramp up the production of the batteries and get their energy density up and make the whole manufacturing process much more simple. Simplicity is the key from what I can gather. He wants to cut out all the little bottlenecks that take place. The one specific example he gave was there's a tab, a physical tab that goes into a battery. He's eliminated that and created a larger battery where you don't need to fiddle around with this tab. The tab actually cuts into the production process. It creates a little bit of a bottleneck, and it creates a stop and start. He wants to basically just manufacture smoothly and in bulk, and to do that he needs to simplify the whole process, and that's what his whole philosophy is about, is to keep it cost effective and simple, and to be able to churn out batteries at an unprecedented rate. He's talking about surpassing the gigafactory concept. Now he's talking about a terafactory. So he's talking about a 1,000-fold increase on the output of the current gigafactories, which are pretty amazing in themselves. So this is a sort of change that's going to be taking place with Elon Musk. The presentation was quite bizarre because he actually he used a bit of razzmatazz there by having all these Tesla owners in a car park, and when he came up with a big announcement, they would beep their horns. So it was like watching a drive-in. It was really quite bizarre. It's typical of Elon chasing a bit of publicity, doing something a little different, which is laudable, I think. He's not your average CEO.
So let's get started. We have a plan to halve the cost per kilowatt hour, and we're going to go through that plan with you today, step by step, and build up how we get to these goals and how we accelerate this transition and make our vehicles and our grid batteries more affordable. We came up with tabless architecture that maybe you've heard about. Basically removes the thermal problem from the equation and allows us to go to the absolute lowest cost form factor and the simplest manufacturing process. And this is what we mean when we talk about tabless. We basically took the existing foils, laser patterned them, and enabled dozens of connections into the active material through this shingled spiral you can see. With simpler manufacturing, fewer parts, 50 millimeter versus 250 millimeter electrical path length, which is how we get all the thermal benefits.
Yeah, this is important to appreciate. Like basically the distance that electron has to travel, is just much less. So you actually have a shorter path length in a large tabless cell than you have in the smaller cell with tabs. This is a big deal. So even though the cell is bigger, it actually has more power. The power to weight ratio is actually better than the smaller cell with tabs.
As you make cells larger, in fact, supercharging and thermals in general become really challenging as you make bigger cells. And this was the challenge that our team set our sights on to overcome. So as you can see, we kind of swept the key figures of merit, how much we can reduce the cost and how much vehicle range increases as we change the outer diameter of the cell. We found a sweet spot somewhere around 46 millimeters. And so when we put it all together and go to our new 80 millimeter length, 4680, we call this new cell design, we get 5 times the energy with 6 times the power and enable 16% range increase just form factor alone. I want to stress, this is not just a concept or a rendering. We are starting to ramp up manufacturing of these cells at our pilot 10 gigawatt hour production facility just around the corner.
Basically, so the first thing was to remove these tabs. He's done that. This is actually something he has achieved. He has a larger cell which is providing better energy output and improving the performance of the cars. And it's an easy thing to manufacture, and that's very important to him. The other thing he's trying to do is eliminate the liquid part of the battery. And he's bought Maxwell Technologies so that he can actually roll on a dry electrode onto the battery. and that will also simplify the manufacturing process.
Let's stack up everything we just saw at the cell level. So just the cell form factor change enables a 14% dollar per kilowatt hour reduction, just that cell form factor change. One of the most important processes is where it all begins, the wet process of the electrode coating. You've got mixing where the powders are mixed with either a water or a solvents for the cathode. That mix then goes into a large coat and dry oven. Wouldn't it be great if we could skip that solvent step, which is one of those dig a ditch and then fill it kind of things where you put the solvent in and then take it out and recycle it, and just go straight to dry mix to coat. And that's what the dry process really is about. You can see it here on a bench top. Literally powder into film. As simple as that.
I would not say this is like completely in the bag. It's still a lot of work to do. And you know, as you go from like benchtop to lab to pilot to volume production, there are actually major issues that you encounter at every level.
So you can see the motivation. A 10 times reduction in footprint, a 10 times reduction in energy, and a massive reduction in investment.
So he's got a number of fronts where he's attacking. He's trying his hardest to squeeze as much out of each process as he can at the lowest possible cost and providing the greatest output of energy. So it's quite an ask, and he's a determined man, and he's pushing ahead with this. But this particular technology, the dry electrode technology that's from Maxwell Company, he bought, I think, for about $425 million. It was a good investment by the looks of things, because he is the number one player when it comes to EV production, and he needs the best technology available to provide the cheapest, cost-effective production lines to churn out these batteries, so to make EVs a really cost-effective alternative to the internal combustion engine. And he's not far off it, but investors were actually disappointed because he's looking at about a 3-year time frame. The dry electrode technology isn't quite there yet. He's gone through 5 iterations of this technology trying to roll it on, and it isn't working yet. So he's going to try a 6th time. He's determined. He continues to refine the processes, and it's a lot of hard work basically. It's not glamorous, and I think a lot of investors are expecting like a magic bullet, like saying, oh, we'll have a dry cell electrode that will give you 10 times more energy capacity. Well, that's the sort of stuff that just doesn't happen overnight. And he's basically continually improving the process to get the greater energy density, to get greater range for the car, lower weight for the car, so that all these things come together to basically lead to to what his ultimate goal is.
What does this mean for our future products? We're confident that long term we can design and manufacture a compelling $25,000 electric vehicle.
This is to have a $25,000 car, which is much more in the ballpark with other automobiles on the market at the moment. That's what he's trying to do. That's his goal, and it will take 3 years, and that disappointed investors. I mean, these things don't just happen overnight. They are a long-term slog, and he's good at doing that, and he's determined to just keep chipping away at the price and the production, making the production much faster, churning out the batteries, because there's going to be a huge demand. I mean, Tesla at the moment is not a large automaker. They made about 500,000 cars. That's reasonable, but it certainly doesn't put them in the big league when it comes to manufacturing vehicles. They're going to need to go into just expand the production by, well, I guess at least tenfold, I would think. Maybe more. I mean, it doesn't look like the other EV players. Most of them are going to be really serious competitors, like the Fords and the GMs in America. They're just not providing that competition. Whereas I think the South Koreans are probably the ones that are probably going to be provide the most. And of course the Chinese, depending what happens in China. I'm pessimistic about the whole setup in China. I think there could be a revolution there, so that's not good for business. But that's just a hunch. I've got no idea what's happening behind closed doors. But China is a bit of a worry, so that gigafactory in China I wouldn't be overly happy with. Apart from anything else, I wouldn't be happy with the fact that I reckon that there'd be spies out there nicking his technology, and that's just not on. He also mentioned about actually moulding the shape of the battery pack the way they do with the with airlines, where they do with the fuel tanks. They basically mould it into the shape of the wings. He's thinking of doing something similar with the actual chassis of the car, having the batteries in such a configuration that they'll be much lighter and more efficient.
So it starts with having a single piece casting, or a single piece casting for the front body and the rear body. In order to do this, we commissioned the largest casting machine that has ever been made. And it's currently working just over the road at our Fremont plant. We have it's pretty sweet. Making the currently making the entire rear section of the car as a single piece, high pressure die cast aluminum. And in order to do this, we actually had to develop our own alloy because we wanted a high strength casting alloy that did not require coatings or heat treatment. So you're basically making the front and rear of the car as a single piece, then interfaces to what we call the structural battery, where the battery for the first time will have dual use. The battery will both have the use as an energy device and as structure. So this is really quite profound. Effectively, the non-cell portion of the battery has negative mass. We save more mass than the rest of the vehicle than the non-cell portion of the battery. It also allows us to pack the cells more densely because we do not have intermediate structure in the battery pack. Instead of having just a filler that is a flame retardant, which is currently what is in the 3NY battery packs, we have a filler that is a structural adhesive, as well as flame retardant. So it effectively glues the cells to the top and bottom sheet. And this allows you to do shear transfer between the upper and lower sheet. Just like if you have like a Formula One craft or like a racing boat, and you have carbon fiber face sheets and, say, aluminum honeycomb between them, this gives you incredible stiffness. And it's really the way that any super fast thing works is you create basically a honeycomb sandwich with two face sheets. We can actually use the steel shell case of the battery to transfer shear from the upper and lower face sheet, which makes for an incredibly stiff structure, even stiffer than a regular car. The volumetric efficiency of the structural pack is much better than a non-structural pack, and we actually bring the cells closer to the center, and because they're closer to the center, it reduces the probability of a side impact potentially contacting the cells, because it has to go, in any kind of side impact has to go further in order to reach the cells. If you can bring things closer to the center, you reduce the polar moment of inertia, and that means the car maneuvers better. It just feels better. You don't know why, but it just feels more agile. It's really cool. This is really major. Like I said, so 10% mass reduction in the body of the car, 14% range increase, 370 fewer parts.
And it's not just at the product level a better product, but in the factory, it's a massive simplification. So we're looking at over 50% reduction in investment per gigawatt hour, 35% reduction in floor space, and we'll continue to improve that as we make the vehicle factory of the future. In addition to the improvements we just said on enabling additional range and improving the structural performance of the vehicle, it is worth another 7% dollar per kilowatt hour reduction at the battery pack level, bringing our total reductions now to 56% dollars per kilowatt hour.
Yeah.
Range increase, we're unlocking up to 54% increase in range for our vehicles and energy density for our energy products. 56% reduction in dollars per kilowatt hour at the battery pack level, and a 69% reduction in investment per gigawatt hour, which is the true enabler when we talk back about how do we achieve this scale problem here.
Yeah. What this enables us to do is achieve a new trajectory in the reduction of cell cost. And now, to be clear, it will take us probably a year to 18 months to start realizing these advantages, and probably to fully realize the advantages, probably it's about 3 years or thereabouts. So the long-term scaling of Tesla and the sustainable energy products that we make will be massively increased. I mean, long-term, we want to try to replace about, at least 1% of the total vehicle fleet on Earth, which is about 2 billion vehicles. So long term, we want to try to make about 20 million vehicles a year.
So he's just, every area is pushing for greater efficiencies. This is what you'd expect from Elon. He's really fixated on making mass production his forte. He's really going for it. He's basically almost like the reincarnation of Henry Ford in a way, because he was the man who basically invented the production line. It looks as though Elon wants to be the person who's absolutely honed it to the nth degree, so that he's just got the most efficient, cost-effective way of producing batteries, which in turn means you can then produce the cars. It's not the engine that's the problem with electric cars, it's the batteries. Got to get greater density, greater output, longer life. The million mile batteries are a brilliant idea. All these things will come together to basically make EVs the choice for people who want to get around on four wheels. That'll basically be the choice in the future, I think. I think there's no doubt that ICE vehicles will be relegated to specialist areas and won't have the mass market. But we're not there yet. And if Elon can come up with a $25,000 car that's got all the bells and whistles, well, I'd say that it's going to be pretty glum looking for ICE manufacturers, internal combustion engine manufacturers. I think they already know the writing's on the wall. They've been, all their capital is based in that particular technology. This is the great advantage that Elon has, that he's basically gone full boot EV. He doesn't have any internal combustion engine technology, so he's basically got green fields, and it's put him at a huge advantage compared to conventional automakers. So we'll see what happens. But look, I thought it was an interesting presentation. It wasn't as earth-shattering as the hype would make you think. A lot of the information was already available, so it really wasn't opening the eyes of people who have been following EVs. But it was worth watching. I also thought it was quite curious. He had a number of his executives who were wearing masks, but him and his second in command in the EV area, they both were maskless. So I don't quite understand the rationale behind that. But anyway, and of course he did the global warming thing, which disappointed me. I mean, he's doing some great engineering. That's all he needs to do. He doesn't need to pander to these groups. He probably believes it. So I mean, maybe he's not pandering. I shouldn't say that because I don't know what's going through his mind. But he certainly doesn't like business. Places like California stuffing around with his business through the way they're trying to basically stop his production. He's got very little time for those people, and I applaud him for that, because he's a businessman. He may be a little green in the, well, he's quite green actually. I think he definitely favours electricity over other technologies, and I have no problem with that once it becomes cost effective. I don't like it when it means that people are adapting technologies they can't afford at this stage. And that does happen from time to time. So Elon Musk is an amazing character. He's the only guy I know that actually wants to mass produce spacecraft as well. That's something to see. And that's happening in Boca Chica right now. So it's all very exciting stuff. So look, I hope you enjoyed this little change in pace. Again, please give me thumbs up, thumbs down, comment, and subscribe if you're feeling particularly generous. That would be really nice. So it's another nice day here as predicted, and I haven't even been outside yet. Probably should at least pop out to the letterbox. Yeah, I'm going to have a quiet day. So I hope you're all looking after yourselves and having a decent day wherever you are, in Australia or overseas. Bye.